To speed the domination of the world by robots, I built a robot to control the world's Christmas lights. He uses a camera to find colors, which he sends not only to my Christmas tree, but also to Twitter and the CheerLight system, which controls cooperating light displays around the world. To start, I laid out some robot parts and all the things the robot would have to carry. I built a 3-wheel differential drive with an omnidirectional rear wheel. The electrically noisy servos will have their own battery pack. I used recycled sheets of PVC for decking. The 1/4-inch stuff is quite strong for its weight. The color will be spotted by a USB webcam. A Python script running on the BeagleBone Black uses OpenCV to find big blobs of certain colors. The BeagleBone Black is powered by a rechargeable lithium-ion battery pack from Adafruit. For obstacle avoidance, I used 3 sharp infrared distance sensors, one on each side and one in the middle. The BeagleBone can read the analog voltages from the IR sensors, but its voltage limit is lower than what the sensors produce, so I run the sensor output through voltage dividers. It would be nice to mix in a sonar sensor as well to detect things that IR sensors don't read well, but sonar sensors require precise timing that I am not skilled enough to get out of the BeagleBone. The BeagleBone takes add-on boards similar to the Arduino shields, but they are called capes. I used Adafruit's prototyping cape to mount voltage dividers and connectors for the sensors and servos. Because the BeagleBone only has one USB port, I need a hub to connect both the webcam and the Wi-Fi dongle. The BeagleBone Black will ride on top in a plastic case. I cut a hole in the top of the case to allow connections to be made. I wired up several small extension cables for my servos and sensors. Folks around the world have built their own CheerLights displays. For mine, I hacked together a couple strands of GE Color Effects Christmas lights to be controlled by the Arduino in my small CheerLights tree I built for a previous Christmas. Basically, I'm just separating the strand's data line from its controller and connecting it to an output pin on the Arduino. The connection is made with an audio jack that returns the connection to the strand's controller when I remove the Arduino's plug. The CheerBot roams the house, heading in any direction where his infrared sensors do not detect an obstacle. He is also constantly analyzing video from the camera. For each frame, he goes through my list of color ranges. He records the size of the biggest blob of each color range, and if the biggest of all the blobs is big enough, he stops moving and records a higher resolution image of the scene, which he tweets along with the color name. Every found color is immediately reflected by the lights on the tree in my living room. Once an hour, the robot directs the color at CheerLights, which updates the current CheerLights color and changes tree light colors around the world.